Hey everyone, welcome back to the Tenses Titan. Today we are building something really cool, a customer churn prediction system using XGBoost, one of the most powerful machine learning algorithm out there. We will be working with the real telecom customer data, and our goal is to predict which customer are likely to leave the company. This is a super valuable for businesses because retaining existing customer is way cheaper than acquiring new ones. So if you are ready to build a production ready ML system, let's get right into it. So before we start the coding part, let's see what's going to be the workflow for our project. So first we are going to load our dataset, which is a telco customer churn dataset. And after loading our dataset, we are going to do some data visualization to analyze the structure of our dataset. And after the data visualization, we are going to perform some data pre-processing like converting the textual data into the numerical format. And after the data pre-processing, we are going to train test split, which is basically splitting our dataset into the training and the testing set. After that, we are going to train our XGBoost model on the training dataset. And after the training of the model, we are going to evaluate our model on both types of training and the testing sets. And after the evaluation of our model, we are going to deploy our model with the help of the Streamlit so that anyone can use it online. So this was the workflow for our project. Now let's start the coding part. So let me just quickly create a virtual environment for our project and install all the necessary libraries. So as you can see, our virtual environment is now ready. Now we are going to create a file. Let's name it customerchurn.ipynb. We are basically using the Jupyter notebook for better visualization. So now let me just quickly import all our libraries. So import numpy as np, import pandas and pd. This is for the data manipulation. And import matplotlib.pyplot as plt. And cbon as sns is basically for the visualization. Joblib is for saving our model. And warnings is basically for removing the filter warnings. And for the encoding, we are using the label encoder. And train test split is basically for splitting our model into the testing and the training sets. And XGBoost is our model. And we are importing various matrices like accuracy score, confusion matrix, and the classification report for the evaluation of our model. So now let me just quickly run this. So perfect. Libraries are loaded. Let's move on to the data. So now we will load our telco customer dataset. This is a real dataset from a telecommunication company with over 7,000 of customers. After loading our dataset, we will remove the column customer ID because it is just an identifier with no predictive values. And we are also going to fix the total charges column because it has some blank spaces. So we are converting them into the 0.01 and making sure it's a float. Now let's check if our data is balanced or not. So this gives us a 2.77 to 1 imbalance ratio. This is important. So if we train directly on this, our model will be biased toward predicting no churn. So that's why we are using this SMOTE for fixing this imbalance. Now let's visualize some key patterns in our dataset. So here we are looking for three important numerical features, which is the tenor, monthly charges, and the total charges. Then we will look at the churn by the contract type. So as you can see that the month-to-month contracts have way more churn than 1 year or 2 year contracts. The red bars are huge for months to month. This tells us that the contract type is going to be one of the most important features. Customers with longer commitments are way less likely to leave. That's a huge business insight right there. Now we need to convert all our text features to numbers before machine learning because machine learning models only understand the numbers. So that's the reason why we are converting them into the numbers. So if we see the binary features like partners, dependents, so we are basically mapping them yes to 1 and no to 0. And for the categorical features, like you can see contracts or the internet services. So what this will do is like this converts month to 0, 1 year to 1 and so on. And we are also saving this encoder because we will going to need this later when we deploy our model. So at that time we have to encode new customers data the exact same way. Okay, so let's run this. So we encoded 10 categorical columns. All our features are now numbers. Now it's time to split our data into the training and the testing sets. So X is all our features, everything except churn. And Y is just the churn column. That's what we are predicting. So we are basically doing a 80-20 split where 80 is going to be the training set and 20% is going to be the testing set. And the stratify parameter is important because it makes sure both sets have same churn ratio. So now we will run this. So now it's ready that 5,634 samples for the training and 1,409 samples for testing. So our test set simulates brand new customers the model has never seen. Now remember that imbalance we saw earlier. Now we will fix it with the SMOTE. SMOTE is basically like synthetic minority oversampling techniques. So it will basically create a synthetic examples of the minority class, like the churners. It looks at the existing churner examples and create new ones that are similar but not exact copies. So now after this mod, you can see that before mod we have 4,139, which was no churn, and 1,495 was the churn, which was imbalanced. But after this implementation, you can see that 4,139 are no churn versus 4,139 are churn. So you can see that it is perfectly balanced. So now our model won't be biasing toward predicting that no churn all the time, so that it can learn to catch the churners. And here is an important note that we are only applying this mod to the training data, not to the testing data, because we want our test set to reflect the real world proportions. Now is the main part that we are going to train our XGBoost model. XGBoost is a gradient boosting algorithm. It basically builds multiple decision trees sequentially, so where each tree tries to find the errors of the previous trees. It's the algorithm that wins Kaggle competitions and is used by companies like Netflix and Uber. So if we quickly see the parameters, the n estimators is basically like how many trees we are going to use. So n estimator is equal to 100 means we are building 100 trees. And if we see the max depth, which is 5, so each tree goes 5 levels steep, so it prevents the overfitting. And if you see the learning rate, which is 0.1, which is basically used to control how much each tree contributes. So let's train this. So it's done. XGBoost is trained on our balanced data. Now let's see how well it performs. So it's time for the moment of truth. How accurate is our model? So we are going to make predictions on both training and the testing set, and then we will calculate the accuracy and we'll get a detailed classification report. So let me just quickly run this. So as you can see the result, the training accuracy is good and testing accuracy is also very good. The small gap between training and the testing means that we are not overfitting. Our model generalizes well. Now let's visualize our predictions with a confusion matrix. So this what shows is that top left is the true negative. It means customers we correctly predicted would stay. The bottom right is the true positive, which basically tells that customers we correctly predicted would churn. And if we see the top right, which is a false positive, which is basically like how much we predicted churned, but they stayed. So we predicted that they would leave, but they actually stayed. And if you see the bottom left, you can see which is the false negative, which is that we predicted that they will stay, but they churned. So for the business, false negatives are costly. You lose customers you thought were safe, but our model minimizes this pretty well. Now here is one of the coolest part, which is the feature importance. So XGBoost also tells us exactly which feature matters the most. So if you look at this, you can see the contract by far the most important. Remember our visualization month to month customers churn way more and tenor. Newer customers are at high risk. Monthly charges tells that higher charges increases churn risk. And if you see the total charges related to the tenor, and internet service is a type of internet which matters. So this tells the business exactly where to focus retention efforts. Now let's save our train model so we can use it in production without retraining. So we are going to use Joblib to save our model. We are saving both the model and the encoder so that when we are going to check for the new customer, we need to encode it in the same way like we did for our training data. So now that we have our training model saved, let's build a web application so that anyone can use it. We are using Streamlit to create a beautiful interactive interface. So let's start building the web app for our project. So here we are going to load our important libraries like Streamlit, which is going to be our web framework, pandas for data manipulation, and Joblib for loading our model. And then we will set our page configuration like making it wide and adding an nice icon. And then we will load our saved model. We are using the sc.cache resources is basically so that it only loads it once, not on every interactions. So we will load both the XGBoost model and our encoder, which is basically the foundation of our app. So now we are going to have two columns for better layout. The demographic section, which shows the gender, partners, and the dependents. Then the service section, which contains the phone, internet, security services. And then the account section, which shows the tenor slider, contract dropdowns, and the charges. So each input corresponds to a feature our model needs. User just fill the form, which is super simple. And then comes the prediction button. So after collecting all the inputs into a dictionary, we will create a data frame just like in training we did. And then we will encode those features like mapping yes no to the 0 1 and mapping male female to 1 0, and then using our saved encoder for categorical features. And after the encoding, we will make predictions. So we will get both the predictions like 0 or 1 and probability. This is important that we must encode new data the exact same way we encoded the training data. And then we will display the result with a big prediction box which will tell that whether the customer will churn or it will stay. And also it will show the confidence metrics like how sure the model and the risk level high, medium or low. And it will also show a probability chart to show both the probabilities and also show the business recommendations like what actionable should be the next step for this customer. So this makes it super easy for non-technical users to understand and act on it. Alright, so our app is now ready. Now let's see our app in action. So let me just quickly run the Streamlit app. We are going to use the command streamlit run churnapp.py. So here you can see that our model is working fine and we are able, let's see now it's working or not. Let's predict a value for it. So as you can see that it is predicting very nicely. So our model is working. Now it's time to deploy it so that anyone can use it. So let me just quickly put all the code on the GitHub. So as you can see that our entire code is on GitHub. Now let's quickly go to the Streamlit cloud and deploy our model. So we are going to click on the create app. And then we are going to select our repository. Then we will select our app file name, which is churnapp.py. And in the advanced setting, we are going to select the Python version, which is 3.10. And then we will click on the deploy. So as you can see that our model is now deployed. Now let's see if it's currently working or not. So as you can see that it is working very fine. Now you have your project completely deployed and anyone can use it. So that's it for today's video. All the code is in the description. Start the GitHub repo and drop a comment with your deployed link. I will love to see your version. So if you learned something, smash that like button, subscribe for more ML projects and turn on the notification. And if you have any question, drop them in the comment. I will reply to everyone. So thanks for watching and I will see you in the next video. This is Tensor Titans signing off.